Everyone, it's Coach Fred, and so today I'm going to be going over what we ended with class the other day. We started talking about piecewise functions, and these were just functions that were like pieces of other functions. So the one we looked at in class was pieces of different lines. And what we recognized was that they all were on a certain domain. Each segment had its own specific domain that we were looking at. And then we looked at how you might find the domain of each one, or what part of the function actually provided the domain. Now, here was an example where we had three different functions, and these were the domains that we were looking at. Today, I'm going to show you how to graph a piecewise function. Okay, so first, when we look at it, I want to think about how many equations I think I'm going to have to write the rule. So in this case, I can see that I have two little pieces. It looks like two pieces of lines. So I'm going to have two rules or two equations in my piecewise function. So the first thing that I'm going to want to do is I'm going to want to, let me grab my pen. I'll do it in purple today. I'm going to want to write my domain. So I start with f of x equals, and I'm going to put a little squiggly mark. But I want to get my domain in first. So I can see that this one on the left, it appears that I'm starting at 3 and I want all the x values less than 3. So I'm going to put x is less than 3. And it's less than because there's an open hole. And then this function on the right, again, a line, I'm looking at it from 3 the other direction. So that would be x that is greater than or equal to 3. All right, let's not worry about the range quite yet. Okay, so this left equation, it's a line, so I'm going to find the slope. So I can see that I'm going down 1 over 1 between points. So that's x, and the y-intercept is 4, so plus 4. The one on the right, I can find the slope, but I can't necessarily find the y-intercept just by looking at it. So let's see what the slope is. We've got up 1, 2, and to the right 1, 2, 3. So my slope is 2/3. And that other slope was negative, so forgive me on that one. So 2/3 x. And then if I think about it, I would have to go down 2 and to the right 1, 2, 3. So my y-intercept is actually going to be positive 2. All right, so that would be your piecewise function. Now the range, so let's look at the range. Now remember, range is a little bit trickier because it's y values. So the range for the first domain would be from 1 all the way to infinity. But it would be a parentheses, so 1 to infinity. Whereas the range for the rightmost function would be from hard bracket 4 to infinity. Remember, range is always my y values. All right, so let's get more specific with piecewise functions. What if I actually want to graph the piecewise function? All right, so we're going to complete a table of values here over the given domain because I want you guys to see what would make it a little bit easier. All right, so if I plug in -5, I have to go to this function, so that's going to give me -10. -3 is also that function, so that's going to give me -6. 0 is also that function, so that's going to give me 0. 1 would give me 2. And 2, I'd actually have to jump to the other equation. Why? Because it actually equals 2 at within that function. That's within the domain. So that would be 5. 2.1 would be 5. 2 would be 5. 3 would be 5. 4 would be 5. And 6 would be 5. Okay, so I've got all my points. And so now let's answer some of our questions before we get to our graph so we really understand what's happening here. So we plotted the ordered pairs. But before I want to graph, I want to look at how many pieces of the graph we have. So we know that our graph's going to have two pieces because there are two functions, two specific functions. There's f of x equals 2x, and there's f of x equals 5. Now, the big question here, are the pieces rays or segments? Well, because these are compound inequalities, these are actually going to be segments. So that's important, okay, segments. Why? Because we have compound inequalities. And let me go back for a second so you can see what I mean. Like on this function, it had an arrow. You can see it was a simple inequality. It was saying all x is less than 3. It wasn't between values. This domain, I'm looking between values, so they're going to be segments. Are all the endpoints solid dots or open dots or some of each? So I can see that I have an open dot here, closed dot here, closed dot here, closed dot here. Okay? All right, we're going to graph from there. So we got through questions 3, 4, and 5, and we'll go back to the remaining questions after we get this graphed. Okay, so I have a point -5, -10. I've got -3, -6, right about there, 0, 0, 1, 2. But what about this guy of 2? That's the tricky one. I have got to have a segment with an endpoint on the x-coordinate of 2, so I really need to plug 2 in, which is going to give me 4. So that's got me at 2, 4, but it's going to be an open circle. And there's my segments. Okay, let's go to the other one. We see that it's a constant function. It is a closed circle between the segment. So I have a closed circle here. I'm going all the way to 6, like that. And you can see again, it is a piece of a function. And it says, were all these x values necessary to graph the piecewise function, or could this have been graphed using less points? So this is important. You know, if we look at this segment right here, if I had this point, and I knew it was a line, couldn't I graph it? So yes, we don't need all of these x points, okay? The ones that were critical for us, because these were lines, were actually the -5 and the 2, and the 2 and the 6. So those are going to be the critical points if my piecewise function is linear. If it's not, we have to look at it slightly different. All right, so we're going to graph this piecewise function. I'm going to create a table of values for the piecewise function over the given domain, but I'm only going to use the critical points. So I'm going to use critical points. All right, so I'm going to take the first function. I'm really neat about this, guys, because when we get into really difficult piecewise functions, you can have a lot going on. So I'm going to do f of x equals x plus 3. That's its own function. I'm going to make a quick table. And because it's linear, I'm going to use -8 and 1. So if I plug in -8, I've got -8 plus 3, which is -5. 1 plus 3, which is 4. I have 2 points. I look at what I need at those endpoints. I need a closed circle and an open circle. So -8, -5, it's right there. It's going to be a closed circle, and at 1, 4, it's going to be an open circle, and because it's linear, I know I have a line going through there like that. And again, it was a segment because it was a compound inequality. All right, I'm going to look at my other function, 10 minus 2x. I'm going to make my quick table. Hopefully you guys are actually ahead of me now. Points I'm going to plug in are going to be 1 and 7. All right, so 10 minus 2 is 8, and then 10 minus 14 is -4. All right, so at 1, I'm going to have a closed circle, so 1, 8, closed circle, 7, -4, also a closed circle, and there I have a line in between it. All right, guys, so that is how we graph piecewise functions. We're going to be looking at piecewise functions every unit we go into this this year, so you'll get really good at them. For now, we're just going to look at linear piecewise functions. I did make a few videos on the challenge problems for fractions, so I'd like you to, if you got any wrong, or I said see me on these, you might want to take a quick look at those videos that I posted on the website. Okay? Have a great day.